one thing we've talked a lot about with investors is what we've had to do to pass the requirements in Japan. And one of those things is grid code. So here we are with Jonas Molén, head of R&D at Climeon. Jonas, can you explain, what is this? What is grid codes?
Yes, I'll try to. And this is a, grid codes 101. So it's not all the details, but it's an introduction. So if we start using, we can use Sweden as an example. If you have Sweden like this, is our country. We have a lot of users of power in the south, all over the country, and we have big generators here and there in the country. In Sweden, hydro plants and nuclear power plants. These are huge and they're strong. And if we have a small problem somewhere where the people use the power, like here, if there's a small problem, a fault, these strong generators, they will just keep winding and pushing out power, giving the grid time to isolate the problem and disconnect it. So this small problem here will be disconnected from the grid, and the grid stays alive and everything is up and running, thanks to the strong and large generators in the background. When you, in the green transition of the power systems, you move from these stronger ones, big ones, to smaller and distributed generators, things like solar, wind, and all kinds of more localized energy production. That grid, so this is not an actual country, but it's got lots of small generators like this, and then you also have the consumers. Now if I have a localized fault in this place, then all of the surrounding generators will sense that the power, it consumes too much power and the voltage is disturbed or the frequency is disturbed. And all time, these small guys used to disconnect, meaning that this small problem here causes a local disconnect. And then this ring of generators also disconnect. So it causes a fault that goes through the power grid like an avalanche. Grid codes are rules that are intended to stop this, these problems from propagating throughout the field, throughout the network or the grid. So that what it says is that the closest guys here, they're not allowed to disconnect. If there's a fault, you need to stay online and stay connected to the network for like half a second to a second. That gives the network time to isolate the problem so that everything else can stay up. So that is grid codes. New rules for generators so that these kind of networks or grids can keep working.
And that's what you've been testing for Japan.
Exactly. So what it means is that our module back here, if there is a fault, so that voltage drops or frequency changes or so on, we used to just disconnect, like all small generators. But grid codes, they require us to stay connected to the grid and try and deliver power, so that if the fault time is like half a second or up to a second, we're not allowed to disconnect. We need to stay connected and keep delivering power. And that adds new requirements to our modules. And it's the same also for other green energy producers like solar and wind and so on. The difficulty with this is that to test it, you need to be able to produce a fault. So we've had to build a test rig that can put our generator into a fault and then measure and see that it behaves as expected. And that's the difficulty with testing grid codes. Also, requirements are different in Japan, UK, Germany, US, Sweden. It's still, there are international standards being developed, but it's still a local rule, so it changes from country to country. I'll show you quickly for the grid codes. We have, this is the module we're running, testing grid codes on. These things here are the electrical cabinets running the module. And then we have this strange thing here. So this is the kind of test cabinet for grid codes. This thing can produce faults. So we can program this to change frequency or lower the voltage or simulate short circuits and so on. And at the same time, it also measures what happens. So with this one, we can introduce a fault and measure how our system copes with it. This test data is something you need to give to grid owners to prove that you comply with the grid codes. So this is a key thing in what we're doing right now. And apart from that, We're also running tests on some of these other modules, aiming to comply with new country requirements, like going into Japan. They have other rules for pressure vessels and electrical work and so on. That has been tested. We're also trying to improve just general performance, like output, performance, efficiency and so on. And that's always